All right, so I'm going to go through and identify types of reactions first. So first one is synthesis, because I have one product. Okay, notice I only have one thing, H2O there. Here I have single replacement, because I have an element and compound on both sides. Here I have decomposition, because I have one reactant. Again, synthesis, one product. Double replacement, because I have two compounds on both sides. Here I have combustion, because I have CO2 and H2O as my products, which makes that one also combustion. Here I have two compounds on both sides, so it's double replacement. Here I have single replacement because I have an element and compound on both sides. And then here I have decomposition because I have one reactant. Okay, so just go back and pause there if you need to get those to double check. Oh, sorry, this should be decomposition. Okay. So pause if you need to. Now I'll go into balancing. So remember, you're multiplying. You can only put numbers out in front. So I need a 2 here to balance my oxygens. Then I have 4 hydrogens on this side now. So that means I need to put a 2 here to give me 4 hydrogens. And I will not write 1s in all the blanks, but realize that there is one O2. It is not a 0. To balance, I need a 2 there, and that's all I have to do. Now this one is tough because I got oxygen in 2 spots. So if you see something like that, oxygen in 2 spots, do that last. So here I have 2 sodiums, 1 carbon, 3 oxygens, and 1 plus 2 oxygen gives me a total of 3. So that one's actually balanced how it is. Need a 2 there for Cl, gives me a 2 there for Na. Now this one's a little bit tough. Okay, these things we haven't talked about really a whole lot here. So we got PO4. Notice how it's the same on both sides. The only difference is here I have 2 of them. That means I have 2 PO4s. So on this side, I would need 2 PO4s. Again, notice how I have SO4 the same on both sides. I only have 1 SO4. I have 1 of each of them. Okay, so when I'm balancing, I'm treating SO4 like one item. Sometimes it's helpful to circle them like this. So over here I have 6 hydrogens, so I need a 3 here. That gives me 3 SO4s, so I need a 3 there. That gives me 3 CAs, and so forth. Now, one thing to note, even if you weren't quite sure about the endings, and I'll redo it this way, you could just look at calcium and hydrogen in balance. So I have 3 CAs, I have 3 CAs. I have 2 hydrogens and 3 hydrogens. To make them equal, there I need a 3 there and a 2 here. And then in that situation, even if you weren't 100% sure about the polyatomic ions, you'd probably be okay because I end up with the same numbers. That's not a perfect way to do it, but it does kind of work. Well, we'll talk about it in this problem as well. And I'll come back and do that combustion. So again, ALs, I have 1 and I have 2, so I'm going to double my ALs first. And I have 2 H's, and over here I have 1. So you might think like, oh, if I put a 2 there, then I'm probably good. And in this case, like that's a good place to start. But I do have to look at my endings because right here, I have 2 H's and then 2 NO3s. Over here, I have 2 times 3, which is 6 NO3s. So it turns out that 2 didn't help me. I need to put a 6 here. And then I need to put a 3 here. And that's going to be 3 SO4s. Over here, I have 3 SO4s, and I'm good to go. So combustion, I have oxygen in 2 spots, so I'm going to do that last. I'm going to do an 8 here and a 9 here to balance my oxygens and hydrogens. And then I got to add up. Here I have 16 oxygens and here I have 9. Notice this is going to give me an odd number. So what I want to do is instead I want to double this 25 to 50. But in order to do that, I have to double my 8 and my 9. So I get to 16 and 18. And that's going to give me, if I were to redo it, 32 and 18 oxygens here. But in order to do that, I had to double my carbons and hydrogens. Now, in order to get 50, I just have to put a 25 out front there. Okay, so if you have that situation, sometimes that can happen in combustion. If I get an odd number of oxygens, I just have to double everything. Okay. Now, this is a tough one because I got oxygen in 2 spots on both sides. So I'm just going to do oxygen last. I'm going to do my carbons and hydrogens first. Then we figure out, okay, how many oxygens do I have on this side? Because ideally, I don't want to change this number. Because if I were to put a 2 here, that would make this number and this number wrong. Okay, so my goal is to keep this a 1. I'm going to put a 1 there just so I mentally don't change it. So I put a 12 here. and a 6 here because that's how many oxygens I have. So I have a total of 18 oxygens. And what I want to do is I want to keep a 1 here. So I have 6 oxygens. So 6 plus what will give me 18? It's 12. So if I put a 6 here, that'll give me 12 oxygens, and I'll be balanced. I need a 2 there to balance, a 2 there to balance, and then I'm good to go. Now, my guess is a lot of people started with a 2 here, and then you realize like, oh shoot, my oxygens are different. So I have to come back and change it. Okay, so really what you want to do is you want to put, if I have an odd number of oxygens and an even, just double this one and then figure it out. So make that one even. So I have 6, and then I have 3 here. That gives me 4 potassiums and 2 carbons. Now notice 4, 2, 4, 2, and 3, I could reduce these ones, but I can't reduce the 3 by 2 as well. So that tells me that this is actually all good to go. And that's it. Let me know if you have questions. If you guys could balance these and identify these, you're just going to do just fine on the test next week.